So OpenAI O1 has some big claims. It's supposed to be better at reasoning, PhD level science questions, coding, math, etc. And from some of my early tests, this does seem to be the case. It seems to be much better than anything else we've seen so far. But let's put it through the gauntlet of some really hard-hitting questions to see what it can really do. So first and foremost, can it make games? I was really impressed with Claude's ability to not only create code, write code for games, but also iterate on it and add new abilities, new functions, and keep everything straight without having it all break down, without losing functionality, etc. Let's try to see if O1 can do the same thing. So create a snake game. The fruit that the snake eats will actually be Dungeons and Dragons characters. Each time the snake eats one, it grows 10 units. This will allow us to kind of just troubleshoot more quickly. Let's take a look at the reasoning here. So it summarizes kind of like what it's been asked to do. Thinks about what kind of like Python sort of libraries and stuff it's going to need. What functions is going to need, such as, managing movement, ensuring collision detection, and incrementing snake length. So far, so good. Setting up the canvas. That's really good. And here it is. We have the code. All right, so here it is. Let's try it out. And it's looking pretty good. Looks like it's using just text to describe what the things are. Cleric, druid, paladin, very cool. Oh, so we're actually eating the good guys here. We're eating the paladins, etc. I thought it was going to be more like goblins and dragons, but this is cool too. This is going to be like Dungeon Keeper 2, etc. Let's see. Okay, yeah, this is very cool. It grows by 10 each time and iterates really, really well. And if we hit ourselves, we collide with ourselves, the game ends. Very good. And this is where it gets interesting. So the whole point is to test its ability to iterate on this code. So we're going to add a bunch of functionality. And the goal is to see, can it add the functionality while keeping all the original stuff in there without anything breaking? Let's check it out. This worked great. Let's change the characters from things like paladin to monsters like goblin and dragon. Also add a score. Each character eaten will have its own value, a number of points added to the score. Try to make the number of points equivalent to the relative strength of the character. A dragon will be worth a lot more than a goblin, etc. Also, add falling objects from the sky. When an object hits the snake, it cuts that part of the snake off from the head. Now, this sometimes doesn't work with other models. You have to kind of make sure you phrase it just right. Some models can't even do it no matter how you phrase it. But for example, with Claude, it did it extremely well. It was very, very impressive. So this, I would say, is a very, very complicated prompt. Notice we're not doing any easy prompts here. We're hitting this thing with the hardest things we have. So let's see how it performs. So transforming the game. So it gets the point that we're starting with what we already did, and we're kind of adding more on top of it. Tracking monster consumption is essential. Very, very true. I like the fact that it thinks through kind of not just what we're asking it to do, but also like the point of what we're asking it to do, right? Sort of the why behind the why, if you will, right? So it's saying adding a score display enhances, tracking the monster consumption, marking a significant game development advancement. This might not seem like a lot, but I feel like as this thing gets more complicated and just smarter, little things like that really is going to help it kind of produce better results, because it's not just doing what you're asking it to. It first seeks to understand what is it that you really want. So adding a score isn't just to have a score, it's some sort of a addictive, kind of more engaging element to get you more involved with the game, some sort of a dopamine feedback mechanism. It's thinking through the falling objects quite a bit, and this is where a lot of models completely fail. If this thing gets it on the first attempt, wow. All right, let's check it out. All right, and there it goes. Oh, we have a troll. That's very good. Oh, and I can see the falling objects from the sky. Okay, so I'm still trying to kind of figure out what exactly it's doing when I intersect with the thing. Oh, I see. Okay, I gotta say, first and foremost, it's really, really close to what we wanted, and it produces a functional thing. It's really, really good. The score system is working. We have various orcs and monsters and etc. The only complaint that I have is where the falling object intersects with the snake, it actually resets the snake to that position where the collision happens instead of kind of cleaving the snake in two. But I gotta say, it gets a lot of points here. This is very, very, very good. And by getting a lot of points, I mean, thumbs up. You did a great job. But let's see if we can make it do the thing that we kind of intended it to do. I'm going to say this is great. One small change. When the falling object hits the snake, it cuts the snake at that point. The front of the snake continues as normal, and the back gets cut off and disappears. So let's see if it's able to do that. Notice though, at no point did it throw up any like errors or bugs, or like the code worked every time, which is very impressive. Yeah, so when the falling object hits the snake, it should cut off the tail of the snake from the collision point onwards, allowing the head to continue as normal. All right, so now we got the code, and here we go. Everything's perfect so far. Lich King. Let's see if we can intersect with one of our little, absolutely phenomenal. Unbelievable. At this point, I gotta say, I think this is better than Claude's coding ability for sure. Very, very, very impressive. Wow. It's beautiful. Let me see what happens if we hit one of these things head on. Let me see if I can. Okay, it does it flawlessly. Everything is perfect. No complaints. A+, 10 out of 10. Would code with again. All right, next let's test it with some basic kind of reasoning questions. And we're again kind of going for the more harder ones. We're skipping all the easy ones, all the softballs, and we're going kind of for the harder ones that large language models tend to fail at. So here's one that's kind of old school that's been appearing in different tests and different formats. So Bob is in the living room. He walks to the kitchen carrying a cup. He puts a ball in the cup and carries the cup to the bedroom. He turns the cup upside down, then walks to the garden. He puts the cup down in the garden, then walks to the garage. Where is the ball? Can you spot it? Did you lose track of it? Where's the ball? This is a fiendishly difficult problem for large language models. The trick being that when you turn the cup upside down, what happens to the ball? One thinks that the cup is in the bedroom. Very, very good. So in the kitchen, Bob puts the ball in the cup. He carries the cup with the ball inside to the bedroom. In the bedroom, he turns the cup upside down. At this point, unless specified otherwise, the ball would fall out of the cup onto the bedroom floor. He then walks to the garden, leaving the ball behind. Since the ball likely fell out, he turned the cup upside down in the bedroom. It remains there. Now, I'm kind of getting the chills here because for the last year, 2 years, however long it was, testing a lot of these models, they all fail at certain things repeatedly. Sometimes they get it, sometimes they don't, but it almost seems like a coin toss. This is the first model that just repeatedly nails the reasoning. I haven't seen anything close to this. This is shockingly good. Let's try it again. Mabel's heart rate at 9 a.m. was 75 beats per minute. And her blood pressure at 7 p.m. was 120/80. So we're kind of giving her status at 9 a.m., 9 in the morning, and we're giving her status at 7 p.m., 7 at night. We're saying she died at 11 p.m., but was she alive at noon? It thought for 4 seconds, so that didn't take long. So yes, Mabel was alive at noon. I concluded that Mabel was alive at noon by noting her status at 9 a.m. and 7 p.m. and determining the interval between those times. So yes, Mabel was indeed alive at noon. There are 5 square blocks stacked on top of one another. You are given the following information about them. The second from the top block is green. The fourth from the top block is not green. Assuming that these two premises hold, disprove or else prove the following conclusion. There's a green block directly on top of a non-green block. Explain your answer. So it thought about it for 15 seconds. Here's the thinking process. Then it breaks down what's given, the approach. It visualizes kind of what blocks 1 through 5 are and works out the correct answer, that it is necessarily true that there's a green block directly on top of a non-green block. The conclusion is proven because in all possible arrangements that satisfy the premises, the conclusion holds. Answer proven. Next, we give it the question that's called murder or suicide. Now, we don't actually say that to the model. That's a hint as to what's supposed to happen. But basically, somebody who lives in the Dreadbury mansion killed Aunt Agatha. And then you have a sequence of sort of premises like the only people who live there are Aunt Agatha, the butler, and Charles. Charles hates no one that Aunt Agatha hates. The butler hates everyone not richer than Aunt Agatha. And Agatha is not the butler. No one hates everyone, right? So basically, you're given a list of premises that when you work through everything, the only possible conclusion is that Aunt Agatha killed herself. So it thought about it for 37 seconds. And this is where it gets so interesting to me because note this. What's interesting here is that it kind of goes back and forth. It's saying Aunt Agatha might dislike herself enough to commit suicide, though that's still speculative. I'm piecing together Aunt Agatha's lack of self-hatred, which excludes her as the killer. But as it goes through everything line by line, it actually rethinks its earlier assumption or its earlier gut feeling, I guess, if you will. it's wondering about the hate exclusions. I'm thinking through the idea that everyone could exclude oneself in this logical context, which clarifies, and Agatha dislikes only Charles, not herself. Mapping out the hate, that's an interesting way of putting it. And finally, piecing together the clues, I'm examining Aunt Agatha's animosity towards herself and Charles, noting that the killer cannot be wealthier than the victims. This aligns with her self-hatred and disdain for Charles, suggesting she is indeed the killer. Aunt Agatha killed herself. Notice this is kind of the invisible sort of thinking. And then the answer starts with the answer. It's the first line, and the proof follows. It lists out the possible suspects, the premises. By the way, if it ever gets anything wrong, it would be extremely easy to go back and figure out exactly where it went wrong. And after kind of like showing its work, showing its proof, it concludes, therefore, Aunt Agatha killed herself. And then it even kind of reiterates it in a very strange way, saying Aunt Agatha is the murderer of herself, which is a weird way of putting it. But wow. Again, this is the first time we're getting answers like this from a model. Next, we have 7 cards are placed on the table, each of which has a number on one side and a single colored patch on the other side. The faces of the cards show 50, 16, red, yellow, 23, green, and 30. Which cards would you have to turn to test the truth of the proposition that if a card is showing a multiple of 4, then the color on the opposite side is yellow? Unfortunately, or I guess fortunately, immediately it understands that this is the Wason selection task. It figures out that the condition that it needs to test for is if P, then Q. P being the card shows a multiple of 4, Q being the opposite side is yellow, and the proposition if P, then Q. This is a pretty difficult problem. In fact, when I was doing the test of the Grok system, I still managed to screw this up and get the wrong answer, because this thing particularly kind of plays on our biases. We want to confirm that we're right. The whole thing here is to try to find a situation that disproves the statement, right? So this is kind of the statement that really explains, and props to O1 for this, for really explaining what the situation is. So the only scenario where the proposition is false is when P is true and Q is false. That is, a card shows a multiple of 4, and the opposite side is not yellow. Steps to determine which cards to turn over, right? So 16, this is a multiple of 4. We need to check if the other side is yellow. If P, then Q. So if it's 16, which is a multiple of 4, then Q must be true as well. The opposite side is yellow. If it's not, then we've disproved that proposition. Turn over the cards showing colors that are not yellow to check if the opposite side is a multiple of 4, right? Because if, for example, the red or the green, if we flip it over and it says 4 or a multiple of 4, then this proposition would be false. Ignore cards that show numbers not multiples of 4 and cards showing yellow because, and this is where people, I guess myself included, get it wrong. And so the answer is turn over the cards showing 16, red, and green. All right, here's one that a lot of large language models have really struggled with. And for one reason or another, they've all failed, and they've all failed in spectacular ways, in very different ways. So if O1 can do this, again, this would place it in just a different category from anything else. So we're asking it to create a multiple choice quiz. There are 4 answers, right? So A, B, C, D. Each answer a well-known cliche or proverb, right? So you know those things where people are like, a bird in the hand is worth 2 in the bush or whatever, or better late than never. You've heard them all before, I'm sure. The question is a story that illustrates that proverb. And the answer for this prompt will be curiosity killed the cat. Again, previously, all models have failed this in one way or another. Let's check it out. So it thinks through it. It understands, like, framing the dilemma. It understands what the issue is, and also evaluates some of the other options, other proverbs like better safe than sorry, a stitch in time saves 9, which is really, really good because they will be confusing. They could be similar to the correct answer, but you have to really understand that it's not. So the question is, despite numerous warnings, Tom could not resist peeking into his colleague's confidential files. Upon discovering sensitive information, he accidentally leaked it, causing a major scandal at work and resulting in his termination. This really reminds me of that time OpenAI fired 2 researchers that leaked information from OpenAI, causing a major scandal. Those people being Leopold Aschenbrenner and Pavel Ismailov. What's interesting is I think we believe that the thing that they leaked was the Q-star research, which is, as far as we understand, kind of like the framework, the architecture behind OpenAI's O1 model. So it's just kind of interesting that that's the first thing that this model thinks of is that scenario where he accidentally leaked the information. And yes, curiosity killed the cat is the correct proverb. Again, phenomenal. The first time a model has been able to do this that well. In all the previous times, it would fail. I've tested it on Gemini, on the previous GPT models, on, I believe, Grok and Claude. There's always something that goes wrong. Either it will only put this in, let's say, the number one spot, or it had some like predetermined spot for it. It would never deviate, right? And we're going to test this multiple times to make sure that it randomizes the spots. Or it would like strongly hint at the answer somewhere in the actual question. It was weird. Like it could not create a proper question without somehow giving away the information, which kind of makes sense. If you think about it, it's not allowed to think in the background. It has to say it. So it kind of has to like say everything in there. Whereas here it's able to think through everything and then present just the question. Notice how tight, so to speak, this output is. It only has the thing that you asked for. No thinking, no, sure, let me help you with that. So if you needed to, for example, use it to develop exams or something like that, this would be phenomenal for that because it would output just the thing that you need. All right, so now we're going to have the same exact prompt, word for word. The only thing is the proverb is different. We're going to say the early bird catches the worm. So it thought for a few seconds, it produced it. This one's very simple, like somebody just shows up to the store before and gets the treat. Let's do that again. And this time I'm going to say, make the question difficult and really capture the meaning of the proverb. So hopefully it's going to produce just something just a little bit more harder to grasp, where you have to kind of think about what specific proverb does this represent. And here the proverb we're going to use is, you reap what you sow. You know, it was a good movie, Joker, with Joaquin Phoenix, right? That was really well done. I was really surprised at how good that movie was, right? That whole line where he's like, what do you get when you cross a mentally ill loner with a system that treats him like trash, right? He's on that show. I'm not going to spoil it, right? And then he's like, you reap what you sow, bang. That's not what he says, but it's a good movie. If you haven't seen it, it's a little bit dark. It's a lot of bit dark, but it's not like a Marvel movie or a Batman movie or whatever. It's its own thing. It's a whole other rabbit hole that it goes down. All right, so O1 thought for 30 seconds and says, throughout his career, Tom consistently took shortcuts on important projects. So this is Tom again. So Tom believed that delivering work quickly would impress his superiors more than delivering quality. However, when a critical error in one of his projects caused the company to lose a major client, Tom faced severe repercussions. And yes, indeed, so this shows that you reap what you sow. And this is really good because at first glance, if you're not paying attention, like you could think it's some of these other proverbs. Like you really have to kind of suss out what the correct one is. All right, last one. And this time we're going to use a proverb that's not very well known. Have you heard of this one? I absolutely loved it. I've only semi-recently heard it. And as soon as I kind of got what it meant, it probably became kind of my favorite sort of proverb or whatever. I think it's Polish, if I understand correctly. And it goes, not my circus, not my monkeys. And it basically means like, you're not going to take any interest in whatever drama is happening. It's not your responsibility. You're just going to sit this one out, right? It's minding your own business, not worrying what other people are doing, staying in your own lane, whatever way you want to interpret it. It's just, that's not my circus. Those are not my monkeys. I don't care. So we're going to try this on O1. What's interesting is evaluating distractors. So proverbs like curiosity killed the cat might throw people off. Discretion is the better part of valor could be deceptive by seeming plausible but being incorrect. In a large corporation, a major conflict arises between the marketing and the sales department over a failed product launch, leading to heated debates and blame-shifting meetings, which again also seems to be that maybe this is related to OpenAI somehow, because during that whole fiasco with Sam Altman getting fired, a part of that might have been how ChatGPT was launched. That might have been the thing that caused the conflict between him and the board, or at least one member of the board. And anyway, so Michael, who works in the finance department, is well respected and often sought after for advice. So they're trying to urge him to step in and help. However, Michael decides to focus on his own responsibility, and this would entangle him in unnecessary drama and detract from his work. And of course, the proverb is not my circus, not my monkeys. By the way, during that whole OpenAI saga, the whole drama, you know who illustrates that proverb is, I think, Andre Karpathy, because he was the one that was kind of like, nope, I'm not getting involved. I think he was out of like the sort of senior lead people. He just sat that one out. He's like, you guys figure it out. You guys deal with it. I'm just going to chill over here. All right. So the O1 model has defeated, I think, pretty much everything I've thrown at it for the most part. But now the gloves come off and we're going to hit it with some really difficult stuff. All right. You have two ropes. each burns completely in exactly 1 hour, right? So if you light it from one side, it starts burning, and at exactly 1 hour later, it's finished burning to the other side, right? However, they are different lengths and thus burn at different rates. Also, along each rope, the width and the material changes, so they burn at different rates at different places, right? So it's not like they burn incrementally the same. It's just the whole thing, if you time it, will take 1 hour to burn. The only thing you know is that they each burn completely in 1 hour exactly. You have a lighter. How do you measure exactly 45 minutes? Can you figure this one out? So I think it would be probably better to not think of them as ropes, but rather as fuses. But either way, so the O1 model figures out that you light rope A at both ends and rope B at one end simultaneously. Rope A will burn completely in 30 minutes because lighting it at both ends halves its burn time, right? That's kind of the trick to it. So you light at both ends. If it takes an hour one way, then if you light it at both ends, it'll take half an hour to go through the whole thing and meet in the middle or wherever. Again, keep in mind, it doesn't have to burn at the same rate. So it might not meet exactly in the middle, but we know it'll take 1 hour, right? Row B is burning from one end and it will take the full 60 minutes to burn completely if left as is. So then we wait 30 minutes and rope A has completely burned out. At this exact moment, we light the other end of rope B. So keep in mind, rope B has been burning for 30 minutes. So we light the other side of rope B. Now rope B is burning from both ends with 30 minutes of length left. But since we lit it from both sides, that halves the remaining time. So rope B will burn out in 15 more minutes. And of course, 30 minutes plus 15 minutes is 45 minutes. Wow. ChatGPT, or I guess O1. I don't think it failed anything yet. This is crazy. All right. And finally, this is one of the toughest puzzles that no other large language models has been able to answer before this. I already tested this in a previous video and it did nail it. I had to just briefly kind of explain something to it, but let me try to reproduce it here. So basically we must arrange 5 pieces of furniture, A3, on a 3x3 grid in accordance with the following constraints. A must not be adjacent to C. Nothing is to the right of E. If D and A are not adjacent, then B should be in the middle. D is above all others, and E and D are adjacent. So here's an arrangement, for example, that does not satisfy those constraints. We kind of give this as an example of what doesn't work. And we say, can you print out a 3x3 arrangement that does satisfy the 5 constraints? And lo and behold, after thinking for 29 seconds, which is kind of at the higher end of the range of how long it usually takes, it provides us with this. And so here are the 5 constraints. So A must not be adjacent to C, right? So A and C are not adjacent. So that is good. Nothing is to the right of E. E is right here. There's nothing to the right of it. So that is good. If D and A are not adjacent, then B should be in the middle, which it is. D is above all others, which it is. And E and D are adjacent. It absolutely nailed it. On the first try, 100% correct in 29 seconds. This is huge. Anyways, I'm completely blown away by how well this model performs. It answers questions that no other model has, like either really struggles with, or it's kind of a coin toss whether it gets it right or wrong. It's just, it operates at a completely different level to anything else. It is far, far superior to any other model that we have right now at these sorts of reasoning questions. What kind of an impact this is going to have remains to be seen, but this feels big. I mean, we've seen how well it performs at the Math Olympiad questions, at the PhD level physics questions. It's doing extremely well at those benchmarks. How does it translate into real world use cases? I mean, we're going to see, but this feels big. A lot of people have been saying that everything is just hype, that we're not going to see any more further progression with these models, that large language models can't reason, they can't do basic stuff, they keep hallucinating. I think this shows that we still have a lot of improvements left to go. We've been hearing about this idea of Q-star, the strawberry, since basically November in 2023. So kind of like the framework for this, it sounds like it's been around for just under a year, maybe a little bit longer if this was based on Stanford's work and their Q-star work, the self-taught reasoner. We're not 100% sure, but the point is, I think it's very reasonable to expect that big leaps forward like this will keep taking place, that this technology will keep improving. So stay tuned. I don't think this is going anywhere. If you enjoyed this video, consider subscribing and giving me a like. My name is Wes Roth, and thank you for watching.